Dear students, I welcome you to this lesson, that is lenses. Lenses is a topic under geometrical optics. Geometric optics is the section A of physics paper 2. So under lenses, we know that a lens is a transparent material that is bounded by two curved surface or a plane surface and a curved surface. Since it's a transparent material, it uses the principle of refraction of light. Lenses can be made from glass, plastic, water, and other transparent materials. There are two types of lenses. We have converging lenses, which are sometimes known as convex lenses. These are thick, or they are thicker in the middle than at the edges. Then we have the diverging or the concave lenses, which are thin in the middle and thick at the edges. There are different types of lenses. So the types of converging lenses include, we have the biconvex. Bi means two. So for the biconvex, all the two surfaces are convex. We have the planoconvex. So for the planoconvex, one side is a plane surface and then the other side is convex. Then we have the converging meniscus. For the converging meniscus, one side is concave and the other side is convex. So in this case, this side is the concave surface, while this side is the convex surface. So we have also three types of concave lenses. We have the biconcave, whereby all the two sides are concave. Then we have the planoconcave. One side is a plane surface and then the other side is concave. Then we have the diverging meniscus, where one side is concave and then the other side is convex. So those are the different types of lenses. So when we are looking at lenses, there are some terms that we make use of. So we have what we call centers of curvature. Now, a lens is made up of two surfaces, and each of these surfaces are made or are part of a sphere. So centers of curvature of a lens, these are centers of the spheres of which the lens surfaces form a part. Radii of curvature of a lens. Radii of curvature of a lens, these are distances from the centers of the surfaces of the spheres of which the lens forms a part. So radii of curvature of a lens is the distance from the center of curvature to the lens surface, or from this center to this lens surface. Principal axis of a lens, this is the line joining the centers of curvature of the two surfaces of the lens. So if we draw a line which joins this center to this center, then that line is known as the principal axis of a lens. Optical center of a lens, this is the midpoint of the lens surface through which the rays incident on the lens passes and deviated. So basically the optical center of a lens is the central portion of a lens whereby a ray incident at that point passes through and deviated. Principal focus, we denote principal focus by capital F. So we have principal focus of a converging lens and principal focus of a diverging lens. So principal focus of a converging lens is a point on the principal axis where rays which are close and parallel to the principal axis converge to after refraction by the lens. I want you to note seriously that the rays are close and parallel to the principal axis. If the rays are not close to the principal axis, then they cannot be brought to the same focal point. So in our definition, we have to actually tell the examiner or to tell the person who is looking at our work that these rays are close and parallel to the principal axis. Principal focus of a diverging lens. This is a point on the principal axis where rays which are close and parallel to the principal axis appear to diverge from after refraction by the lens. So we have to note that for diverging lens, the rays appear to come from the principal focus. They don't come from there, they only appear to come from it. So from this, we now have that the principal focus of a diverging lens is virtual, while the principal focus of a converging lens is real. So another term is the focal length. We denote focal length by small f. So focal length of a lens is the distance from the optical center of the lens to the principal focus. Then focal plane. This is the plane perpendicular to the principal axis and passes through the principal focus. Paraxial rays. These are rays which are close to the principal axis and make small angles with the lens axis. So here I want to emphasize that a converging lens has got a real principal focus, while a diverging lens has got a virtual principal focus. And thus, for a converging lens, the focal length is positive, while for a diverging lens, the focal length is negative. Also, we need to differentiate between real and virtual images. A real image is an image which is formed by actual intersection of light rays, and they can be formed on a straight line, while a virtual can be formed on a screen. While a virtual image is an image formed by apparent intersection of light rays and cannot be formed on a screen. So when we are looking at lenses, we need to know how to draw the different ray diagrams for different object positions so that we are able to tell the nature, to tell the distance, and to tell maybe the magnification of the image that is formed. When we are drawing ray diagrams, there are three principal rays that we make use of so that we are able to draw an accurate ray diagram. Now, what are the three principal rays we make use of? The first one is a ray parallel to the principal axis is refracted through the principal focus. So if we have a ray that is parallel to the principal axis, this ray is refracted through the principal focus. If we have a diverging lens, a ray parallel to the principal axis is refracted so that it appears to come from the principal focus. A ray through the optical center passes through undeviated, i.e. it is not refracted. That if you have a ray going through the optical center, this ray will go through it undeviated. A ray through the principal focus emerges parallel to the principal axis. If we have a ray which passes through the principal focus, then this ray will emerge through the lens as parallel to the lens. For a diverging lens, if this ray was to go through F, on being refracted by the lens, it passes through as it is refracted parallel to the principal axis. So we need to note that when constructing ray diagrams, we can use any two of these three principal rays. So you just choose any two of the three. Exercise. Now this exercise basically looks at ray construction. And since you covered this part in O level, I'm going to request you to practice what you covered, to draw the different ray diagrams for different object positions. So the first question is, construct ray diagrams and state the characteristics of images formed by a convex lens when the object is placed at 1 beyond 2f, 2 at 2f, 3 between f and 2f, 4 at f, 5 between f and the O is the optical center, 6 when the object is at infinity. So here you are drawing ray diagrams and also giving the characteristics of the images formed. Number 2, construct a ray diagram and state the characteristics of images formed by a concave lens when the object is placed at different positions from the lens. I want to thank you for listening to me, and I hope this lesson was enjoyable and it has benefited you. For this and more resources, kindly visit the link below, www.tricona.sc.ug/e-library. You can visit us at our website, www.tricona.sc.ug, or you can send us an email at info@tricona.sc.ug. Thank you.